Let's dive into a GCSE math question that honestly had thousands of students scratching their heads. It looks like a standard geometry puzzle, but there's a hidden twist, a tiny error in the question itself that made it completely impossible to solve as written. So let's break it down.
So first things first, let's look at the setup. We're going to break down the puzzle exactly as it appeared on the exam paper, because as you'll see, understanding every single piece of information we're given is absolutely critical. Okay, so here it is in all its glory. Question 19. You can see the diagram there with a couple of triangles, and we've got a few key facts to work with. The goal seems simple enough. Find the ratio of side AB to side AD. All right, here's our toolkit. These are all the givens laid out. We've got two similar isosceles triangles. We're explicitly told that AB equals AC, and that A, C, and D all lie on a straight line. And then there's this really important piece. The ratio of BC to CD is 4:21. We're going to need every single one of these. Okay, got all our ingredients? Good. Now for the method. We're going to build the equation step by step, following the exact logical path you'd be expected to take in an exam. You know, the first thing you want to do in a problem like this is just give things names, right? So let's call the length of AB X and the length of AD Y. The entire point of this whole exercise is to find the ratio of X to Y. Now here's our first big clue. The fact that the triangles are similar is huge. Similarity means the ratio of their corresponding sides has to be equal. So we can set up a proportion, do a little bit of rearranging, and boom, we get this really handy expression for the length of BC, all in terms of our variables X and Y. What's next on our checklist? The straight line. This one's pretty, well, straightforward. If A, C, and D are all in a line, then the total length AD is just AC plus CD. And we already know that AC is the same as AB, which we called X. This gives us our second key expression, this time for the length of CD. And now for the magic moment. We have an expression for BC, we have an expression for CD, and the question gave us the ratio that connects them. So let's just plug our expressions into that ratio, and finally, we have an equation with just X and Y. Time for a little algebra. We cross-multiply, expand everything out, and then shuffle all the terms over to one side. And look at that, we get this beautiful quadratic equation. It feels like we're in the home stretch, doesn't it? But this is where things get weird. This is where the whole problem takes a sharp left turn. What happens when we actually check the official answer? So, the mark scheme, the official document with all the answers, says the ratio should be 2:5. Simple enough. This is the million-dollar question. If our logic was solid and the answer is 2:5, then plugging those values into our equation should make it true. It should all balance out to 0, right? So, does it? And nope, not even close. Look at this. When we plug in X equals 2 and Y equals 5, we don't get 0. We get -24. Our logic was flawless, but it led us to an equation that flat out contradicts the official answer. This is the twist. So, what in the world is going on? Well, you have to feel for the students who sat this exam, because the answer is actually really simple and pretty frustrating. It was a typo in the original question. It turns out the key to unlocking the intended solution was to change just one number. The ratio given in the question should have been 4:15, not 4:21. So let's see what happens when we use this corrected number. We follow the exact same algebraic steps as before, but this time with a 15 instead of a 21. This gives us a new corrected quadratic equation. Now this equation, this one is much nicer to work with. Why? Because it factorizes perfectly. We can split it cleanly into two brackets. And like any quadratic, that means we have two potential solutions to check out. We are so close now. All we have to do is pick the correct solution from our two options, and we can finally state the answer. Well, one of our solutions suggests that a length would have to be negative, which, isn't really possible in geometry. So we can just toss that one out immediately. This leaves us with only one valid possibility. 2y has to equal 5x. And from here, it's just a simple little rearrangement. We want the ratio of x to y, right? So we just divide both sides by y and by 5. And that gets us x over y equals 2/5. And there you have it. The ratio of AB to AD is 2:5. The intended answer, which we could only get to by using the corrected information.
This whole thing really makes you think, doesn't it? It's a perfect example of how one single incorrect piece of information can make a perfectly solvable problem completely impossible. It's a great reminder, not just in math, but in pretty much anything, of just how vital it is to make sure your starting assumptions are actually correct.